Guys, I want to go ahead and talk to you about lesson 8.3, where we're going to begin writing some equations. Last week we took a look at one-step and two-step equations. Today we're going to be looking at how do I build those. And this is really going to be key moving forward. I'm designing a large project that all of us are going to be working on in some way, shape, and form. And your portion is going to be basically larged around writing equations. So when we look at writing equations for multi-step problems, there's kind of four steps that I want you to look at. And the first step would be to identify keywords. You're going to identify keywords that mean add, subtract, multiply, divide, and equals. And I'll talk about that here in a second. Then you're going to substitute those symbols for the words that you see in the problem and substitute numbers and variables that you know or that are given in the problem. Then we're going to check to make sure that things look all right. This will be a big step for us because if things don't look right, we're not going to get the right answer. And you're really going to need to use your number sense in step 3. And then finally, step 4, we're going to solve it just like we did last week with single step and multi-step equations. So I want to go ahead and take a look at two problems here. And these are similar problems that you'll see in your book today. I'm going to use the Chicago Cubs as an example. Pitcher Jake Arrieta threw a baseball 84 miles an hour, which is 21 miles per hour less than twice the speed S that Jon Lester threw. Well, I need to create an equation, and it seems daunting or it seems like it can be difficult, but I just have to identify words that I know that mean certain things. And again, I'm looking for words that mean addition, subtraction, multiplication, division, and equals. First things first, I'm going to go through and identify maybe numbers. So I know I have 84 miles per hour here, which is 21 miles per hour. But then I get a nice easy word here that says less, and I know that means subtract, than twice the speed. Well, this phrase, twice the speed, is a phrase that means multiplied by 2 than what Jon Lester threw. Okay? Well, this seems easy. I've got 3 numbers now and an operation. But this is where now, after I do this, and I've identified those keywords, I'm going to substitute and create a problem. So, we're looking for, we missed one. If we look here, every equation's always going to have an equal sign. So, go back to my problem and see where I see a word that might mean equals. And this hasn't changed since we talked about proportionality and proportion equations. But is another word that means equals. So 84 is 21 miles per hour less than twice the speed that Jon Lester threw. So I'm going to start substituting with what I know, and I like to go left to right. So I'm going to start with 84 equals 21 miles per hour less than twice the speed that Jon Lester threw. Now this can be confusing. If I just write it from left to right, it's going to look like this. 21 less than 2 times the speed that Jon Lester threw. I don't know what that is. Well, let's go with this. Let's see if it works. I've substituted. Now I need to check, and really what I'm checking for when I am in step 3 is I'm looking for number sense. Okay? Number sense. Does this make good number sense? 84 is, sure. 84 is the answer to the equation, is equal to 21 minus 2 times S. Well, what is S? Number sense says it's a speed. So speed, if I think about what I know about baseball, it's probably going to be somewhere close around this 84-mile range. Well, can I do 21 minus twice that speed? Well, 21 minus 84 is going to leave me with a negative number. Does that make sense that a Major League Baseball pitcher is going to throw a baseball with a negative speed? Probably not. So my number sense tells me that this isn't right. My number sense tells me this part is right, but this part isn't. And that's where I can key in on the less than. Whenever you see less than, typically it means that the 21 miles per hour in this case would have to come after the 2 times s. So while this isn't the incorrect formula to write, the correct would have still been 84 miles per hour is equal to 2 times s, and this time I'm going to use parentheses to help simplify that a little bit, less than or minus 21. So now I can read this as 84 is equal to 2 times s minus 21, meaning 21s is going to be 21 miles less. Makes sense. So now I can go ahead and solve, and I solve it just like I did last week using two-step equations. I start by undoing PEMDAS, so I can remember PEMDAS. Please excuse my dear Aunt Sally, and start my way working up. So I undo any operation starting with subtraction, and I have subtraction right here. So I do the opposite to both sides. This will end up canceling, so I'm left with 2s over here, and 84 plus 21 is going to be 105. Now I don't have any addition to undo, no division, but I have multiplication, and I undo it by doing the opposite. So the opposite of multiplication would be division, What I do here, pull up the trusty calculator, because it's an odd divided by an even, so that's going to give me a different number, 105 divided by 2, 52 and a half. So that means S equals 52.5. This would have canceled, leaving me S equals 52.5. Give it a label. Label is miles per hour. So that means John Lester threw his pitch at 52.5 miles per hour, which is 2 times S, or 52.2 or 52.5 times 2 minus 21 gets me back to 84. I can check it. I can put 52.5 back in for X, do the math, double it, then subtract 21, and I should get back to 84. That's a good way of knowing if you get the right answer. But again, I had to identify keywords, substitute, check for number sense. Do things make sense? Did the less than wind up after or before? Did I change that? And then finally solving. Let's look at a second example. Jackie's mother is 28 years old, which is 4 times typo, which is 4 times Jackie's age minus 8 years. So this one's a little more straightforward, and you can see the words maybe a little bit better than you could in the above example. but Jackie's mother is 28 years old. So she is 28 years old. There's that number. There's my equal sign, which is, here's another equal sign, 4 times, so 4 times Jackie's age, which we don't know. Well, I'm going to choose J for Jackie's age, minus 8 years. Minus means subtract. There's another number, 8. So, I'm going to start building. Well, problem signs don't start with an equal sign, so I'm going to ignore this one. But I'm going to say 28 can come first, is 4 times J. So 4 times J, put that in parentheses, minus 8. This one was fairly straightforward. So I've got 28 is 4 times J minus 8. Well, check for number sense. Minus 8 years. So Jackie's age is going to be more because it's being multiplied, but then it's minus 8 years. So I'm going to take a larger number. I'm expecting J to be larger than 8. As long as that is, I'm good. So I'm going to say right now this problem makes good number sense. So I'm going to start solving. Start with my subtraction by adding 8 to both sides. This is your communication. I expect to see it. Cancels, cancels. 28 plus another 8. 8 and 8 is 16. So this is going to be 36 is equal to 4 times J. Now I got to get rid of J, or get rid of the 4. So I'm going to divide, because this was 4 times J. I'm going to divide by 4, and J equals 9. Because 36 divided by 4 is 9. This cancels. So J equals to 9. So that means Jackie is 9 years old. Now, I get to apply my number sense again. Does it make sense that a 28-year-old mother has a 9-year-old daughter? Absolutely. Absolutely it does. So I'm going to stick with this. What the best advice that I can give you to help complete these problems, and it's one that I'm going to ask you to try, is exactly what we went through. Writing the word problems down. They're not very long. So if I open up a new whiteboard, and I am on page 341. And question number 1 says, the quotient of a number and 3 less than 8 is 16. So I'm just going to start writing that. The quotient of a number and 3 less than 8 is 16. I'm going to start by writing that down. That way I have it. I don't have to worry about writing in the book, and I can identify those words. Quotient means divide of a number. I still don't know what number means, so let's that be X and 3. And is a word that means plus 3. Or in this case, a quotient, well, we were talking about dividing. So I got ahead of myself and assumed that it was a plus 3. In reality, you need two numbers to divide. So a number we'll call x and 3. So the quotient of these two, less than 8, less than means minus 8 is 16. Okay? Quotient of a number and 3 less than 8 is 16. So I'm going to start left to right on this one. That's just kind of a good place to start. And a quotient. I can say x divided by 3. I can say x over 3. I'm going to build this two ways. So I've tackled this and I've tackled this. Is less than 8, which equals 16. Here I put parentheses around it to show the problem solver that you'd have to deal with this first and then the 8. Okay, we still honor those order of operations. So if I wanted to solve it, I'd add 8 to both sides. And this would cancel. 16 plus 8 is now going to be 24. So now this is done. Showing you a different way to do this, but it gets the same work. So now I'm at x divided by 3 is 24. Well, I'm going to times by 3. That's going to cancel this and this out. 24 divided by 3. Well, I know 8 and 8 is 16. Add another 8. That is 24. So dividing that by 3 is going to give me 24. And now this is canceled out. So I'm left with x equals 8. So, give you an option here. If you don't want to write this down, you need to be keeping track of words. And what I would do is in your notebook, I'd make a chart for add, subtract, multiply, divide, and equals. And I'd go through each problem and I'd add the word to that list. It can look something like this. Add, subtract, multiply, divide, and equals. In this problem, quotient is a word. That means divide. Is was our add word, and less than was a subtraction. In the second example, we had is 4 times, so we had times. Minus. And you get the idea. Then you can create a chart. So it's really up to you which way you want to attack it. You can make a everlasting chart, or you can write down the words to every problem to use to build your equation. Personally, I think this is the easier route to go. It also makes the most sense because you can see exactly where you got everything for each problem. Your homework is we did 1, so you're going to do 2 through 20 on page 341 to 342. Questions, comments, concerns, please ask. Thank you.